All right, this is the second video of 2 videos talking about how to use the half angle formulas for trig values. And this one's more of an applied, and it also will show you in a second how to solve an equation, right, taking advantage of those half angle formulas. So let's take a look at, first of all, how we can apply it given that we want to find a certain value. Determine the exact value of the cosine of 525 degrees. Now 525 degrees, if we take a look at it, we'd want to subtract 360. Right, 360, so we can figure out where in the world this is going to fall. So 525 minus 360 is about 165 degrees. 165 degrees is going to sit, over in this quadrant, about 15 degrees short of that axis. So this is not a 30, 60, 90 triangle. Right? So again, that's why 525 degrees, right, going around here, all the way over to that angle, is not going to be so easy to find. But if we remember, if 525 is the half angle that we want to try to find, then the original angle, if I just multiply both sides by 2 here, the original angle was theta is 1,000, right, 50 degrees. And in that case, if we kind of imagine where would 1,050 degrees fall, well, 1050 minus 360 is 690. Okay. And I'm going to go ahead and say minus 360. I'm going to go ahead and do some of this work on the side here, though. I'm going to subtract another 360. So basically, 2 times 360. If I subtract 720, I get a 330 degree angle. So again, we're going around here, 330 degrees. So this is going to be a 30 degree reference angle. Right? So this 330 is essentially the same thing as 1050. Okay. And if we have a 30 degree reference angle, now that's something we can work with. Remember, if we want to find the cosine of a half angle, we're going to use our formula here, the square root, right, of 1 plus the cosine of the original angle. Right? Well, the original angle for us, since 10,000 or 525 is the half angle, the original angle was our 1050, right? So again, we're gonna kind of box this off here, running out of room. 1050 there, all divided by, right, 2. Very simply. Now I do know that the cosine at 525 falls into quadrant 2. And I know that cosines in quadrant 2 should be negative. So where we'd normally say plus or minus, I'm just going to include the minus. I already know my answer is going to come up as a negative answer. So now let's go ahead and do some simplifying. Right? Negative the square root of 1 plus. Well, I know that at 330 degrees, cosine's positive, right? We're down here in quadrant 4. And it's basically the cosine at 30 degrees, which I know is a root 3 over 2. And then divide by 2 there. So a little bit of last work here. 1 plus root 3 over 2, essentially times a half, is essentially 1/2 plus root 3 over 4. Or if I imagine this to be a 4 over 2, that might be a better idea. Yeah, let's just go with the half here. So that's going to become, again, multiplied by the reciprocal, 2 plus root 3 right, on there. If we just take that half off the bottom and again multiply by its reciprocal, again, that's what we're going to end up with under here. So there is our cosine there. Let's do the same thing over here at the right. Let's consider pi over 12. Pi over 12 is obviously going to be up in quadrant 1, so that's not going to be a problem there. It's very helpful. But again, pi over 12 is the half angle. So therefore, if I multiply both sides by 2, theta is going to be pi over 6. And remember to find the tangent. We can use either formula. I'm going to go ahead and say 1 minus the cosine of the original angle. Again, the original angle right now is pi over 6, right? Putting that theta in there. And divide by the sine of pi over 6. With a little bit of fraction work, 1 minus, again, the cosine at 30 degrees, as we already figured out, cosine at pi over 6 is root 3 over 2. And the sine at pi over 6 is just a half. Again, we'll multiply by the reciprocal, and we end up with 2 minus root 3, and we have our answer. So again, an easy way to use that half angle formulas, right? Notice here the tangent, or over here the cosine, but a ways to apply that to various angles. Even though the pi over 12 wasn't one of those angles I'm normally used to, right? 30, 60, 90 kind of angles, or pi over 3s, pi over 4s, pi over 6s. Again, if it's the half angle, then the original angle was a familiar angle, right? Pi over 6, or about 30 degrees. Now, last way to use these, again, we can solve equations. Notice in the equation we've got the sine of x over 2. So the first thing I'm going to do is remove the sine, and I'm going to replace it with its formula, right? Plus or minus the square root of 1 minus the cosine of x all over 2 inside that square root. At the same time, I'm going to take a little bit of an advantage here. Knowing that I'm going to have that square root, I'd like to get everything else away from it. So I'm going to go ahead and subtract cosine x over to the right and add 1 over to the right. Because again, in order to get rid of that square root, what I'm going to have to do is square both sides. And I would rather have those two terms away from the square root when I do so. So that now on the left side, plus or minus squared is going to end up positive. Square root squared disappears. I've got 1 minus the cosine of x all over 2. On the right side, we're just going to do a little bit of foiling, or that sort of perfect square formula. Negative cosine squared would be a positive cosine squared. First times the second times 2. If you remember, that's going to be 2 times negative the cosine times 1. And again, 1 squared is just 1 there. In that case, let's go ahead and multiply by 2. So I'm going to get rid of this 2 over here on this side, and I'm just going to run a 2 through this side over here. I'm just going to multiply both sides by 2. And then finally, let's get everything all on one side of our equation. So I'm going to need to add a cosine of x. So that's going to make that middle term negative 3 cosine x, right? I'm going to add 1 cosine, and I'm going to subtract 1, right? I'm going to move these two terms over here, over to that other side. And therefore, don't forget, we still have a 2 cosine squared x when we started. Looks like a perfect time to factor. So let's think about how we could separate those out. 2 times the cosine of x times cosine of x would be 2 cosine x squared. I know I would need to multiply to 1 over on this side. And we know we need to add, essentially, right, to that middle term. So if we put a couple of negatives in there, I do believe that's going to factor or FOIL out correctly. Now we can solve those two separate equations. Again, we've got a little bit of work to do here. But again, separately, 2 the cosine of x minus 1 could equal 0. Or basically the cosine of x, if I add 1 and divide by 2, could be a half. And then in the other equation, again, cosine of x minus 1 could equal 0. Or basically the cosine of x could equal positive 1. Let's draw a couple of pictures. Cosine is a half at pi over 3 and 5 pi over 3. And cosine equals 1, right, at 0. So final answers, x equals 0, pi over 3, and 5 pi over 3. And notice we're just doing simple answers because, again, in the directions up top, we just wanted 0 to 2 pi, right? We just want to narrow down the first answers in that first full circle. I hope that helps you take advantage of, again, those half-angle formulas. Just take advantage of the formula. If you have any questions, talk to your teacher. And otherwise, have a great day.